we will cover this agenda. We will first distinguish between different memory types and check which are the relevant parameters that should be defined and configured for each case. There are also some differences to be considered depending on each platform. We will also cover new features provided in memory management as of kernel release 740. On memory monitoring section, I would like to show you some transactions and reports that can be used in order to monitor the memory consumption on a running system. Finally, we will cover the most common dumps related to shortage on memory resources and how to solve them. So let's start with different memory types. From operating system perspective, we have the physical memory, known as RAM, and the operating system paging file. All this is considered the virtual memory that can be used by the system. It is the operating system who controls where the memory is taken from. From SAP system perspective, the amount of virtual memory available to the application server can be divided into shared memory and heap memory. As its name says, the shared memory is a memory area shared by different processes running on the system, while local memory corresponds to local memory that each process allocates on its own. This memory is also called heap memory and can be divided into priv memory and proc memory. There are three memory types available at SAP level: extended memory, local memory, also called heap memory, and paging memory. We will describe each area and the corresponding parameters that are used to control them in the following sections. Now we will see the relevant parameters that should be known on each of these areas. Extended memory area is used to store user contexts. The user context includes data that characterize the user, like authorizations, administrative information, and other data for the ABAP and screen processors. This information must be shared amongst all the work processes that execute different dialog steps of an SAP transaction. When a dialog step has finished, this information is saved and rolled out to the shared memory. Then it can be rolled in order to be available for the next dialog step of the transaction. Management of this memory area is performed directly by the SAP system and not by the operating system. Its size is defined by profile parameter EM initial size MB, except on AAX server, where the extended memory limit is set by parameter EM total size MB. From all this memory, each individual work process is able to allocate a small part, which corresponds to the quota. This amount of memory that a single user context can allocate from the total extended memory is defined by parameter setTTE role extension. With profile parameters setTTE role extension dia and setTTE role extension non-dia, you can allocate different extended memory quotas for dialog users and non-dialog users. There's one additional quota that needs to be taken into account for a user context in the extended memory, mainly for Windows environment, but also on Linux with map implementation, which is EM address space MB parameter. This parameter should be big enough to allocate the extended memory quota setTTE role extension plus the extended global memory. The extended global memory is located in the extended memory. Its size is mainly defined by parameter EM global area MB and other few areas. This area is reserved for global data that is user independent and work process independent data. The amount of data involved in this area is smaller. Normally should be between 5 and 10. Normally, this should be set between 5 and 10% of the whole extended memory pool. This is because only administration data belonging to internal communication between SAP kernel components. Okay, going back to our presentation, We were talking about the extended global memory, which is part of the extended memory. It's normally set to 5 or 10% of the whole extended memory pool. Only the administration data belonging to internal communication between SAP kernel components is stored here in the global area. Regarding heap memory, this is local memory that can only be used by each work process. This memory can be divided into brief memory and proc memory. With brief memory, the work process is reserved for processing the current user context until the context releases the work process again, once the request has ended. Up to this point, no other user context can be mapped to the work process. The size of the brief memory area is defined by this parameter ABAP heap area total. Similar to what we have just seen on extended memory, each work process is able to allocate a single quota from the total resource. In this case, parameter ABAP heap area dia defines the heap memory quota that a single dialog work process can allocate. For the non-dialog work processes, ABAP heap area non-dia quota applies. When a user context releases its local process memory, this memory remains occupied with respect to the operating system on account of this process. It only becomes available for other processes when the process itself is ended. Therefore, this parameter ABAP heap limit defines the maximum amount of local memory that a work process can allocate without restarting. This is working as designed, and this parameter should not be changed. Whenever this value is exceeded, work process will be restarted once the transaction has been ended. This is explained on this note. As mentioned on this second note, 2360519, as of kernel version 749, the default value of the parameter has been increased to avoid unwanted or frequent non-dialog work process restarting due to this limit. With NetWeaver 740 Support Package 8, a new SAP storage class called proc memory has been introduced to enable global monitoring and control heap memory consumption over all work processes of an application server. Proc memory is memory that is allocated in the operating system. This memory consumption is also local to each work process, but in contrast to brief memory, it is used for data that is not bound to a specific user context, for example, temporary heap buffers. To limit proc memory consumption, you can use this profile parameter emproc max size MB, setting the maximum size of the proc heap memory that can be allocated by all work processes in total. The default value of this parameter is 0, which means unlimited. Parameter emproc max double P size MB defines maximum allocation per work process. Finally, SAP paging. It enables the memory to be extended at ABAP runtime when a large dataset, for example, is handled. It should not be mixed up with the paging method. So remember that paging should not be mixed with the paging method at the operating system level. SAP memory management concept currently limits SAP paging to cases where the ABAP commands extract, so only where commands extract and export to memory are used. The R3 page buffer is made up of two parts. It first takes memory from the shared memory. So going back to the two parts where the page buffer is made of, we know that first takes memory from the shared memory. The size is defined by parameter RDISC SHM. Then, if more memory is needed, it is taken from disk until the size defined by parameter RDISC maxFS is reached. For 64-bit systems, you also have the option to reserve the memory space for SAP paging completely in the shared memory. This can be done by setting these profile parameters RDISC SHM to the value of the profile parameter RDISC maxFS. This is explained in this note. All those three memory areas that we have just seen can be monitored within transaction STO2 that will show this information. It shows for each area the current amount of memory being used and the maximum amount of memory allocated since the latest application server restart. In the case of the page area, the values are specified in 8 kilobyte blocks. In STO2, column name max used, which is this one, specifies the maximum size of the page file that has been used, including both shared and memory file. If this value reaches the maximum size defined for page memory, which as we have seen is given by parameter rdisPG_maxFS, a dump will be raised. In mem value, which is this column, refers to the part of the total size that will be stored in memory, set by parameter rdisPG_shm. So the value for this parameter is the number that we see on STO2 divided by 8. In this particular example, over 32,000. On disk column, which is this one, is the difference between the whole area and the shared memory. When page in memory is completely stored in the shared memory, on disk value will show 0, as no part is stored on disk. For the extended memory area, if max used reaches the value defined in the column called in mem, all the extended memory has been used up and needs to be increased. I'd like to mention new features on memory management that have been developed as of kernel release 740. They are explained on these 2 nodes that are shown in this slide. Extracting from the first node, we see that role memory is no longer used. All data that was stored earlier in the classic role area is now stored in the extended memory, so memory consumption on this area may increase. Parameters that existed related to role area are no longer used. The second major change is the third administration memory management, which was only available for Windows platform and is now available on Unix platforms too. The values of the individual memory configuration parameters are automatically calculated from the value of the central profile parameter fysmem size, following specific formulas. Regarding the last change explained on this node, as of ABAP release 740 Super Package 8, proc memory has been introduced. It refers to local heap memory in the work process that is not assigned to a user context, and it's limited by the already mentioned parameter emproc max size MB. Not only the role area has been moved to the extended memory. The extended global memory, which is part of the extended memory, now contains the table buffer. This is explained on this second node 2148571. This could cause the application server to run out of extended memory more easily, especially if the table buffer is big and the extended memory size is not big enough. This second node contains the formula that needs to be taken into account for the correct extended memory sizing. Depending on the operating system and the work process type, the memory is allocated by the work process in a 13 sequence. In the case of dialog work process that is shown here on the left, they first allocate the extended memory up to its extended memory quota. Then they take heap memory or private memory until its corresponding quota is reached. In the case of the non-dialog work processes shown here on the right, the heap memory area is first allocated until the quota is reached, then extended memory. But this depends on the operating system. On AAX servers, for instance, allocation sequence follows always dialog work process steps, taking first extended memory and then heap. We have already seen parameters that define resources and quotas on each memory area. They can also be found here in this link. If we execute Rs memory report from transaction SE38, we can see the allocation sequence for dialog and non-dialog work processes. I would like to show you directly on a system. We go to SE38 transaction, and then we call Rs memory. So we can see the allocation sequence. This is defined with numbers 1 for extended memory and 2 for heap memory. In this case, this is a Linux system with STD implementation. So for dialog word processes shown here, it takes first extended memory and then heap memory. In the case of the non-dialog word processes shown here, it will be the other way around. With R's memory report, the extended memory and the heap memory quotas can be dynamically changed, overwriting the value that can be set in the profile. The size of the total extended memory area or the heap memory area cannot be dynamically changed. An application server restart is needed when you change these profile parameters. There are some differences that we should take into account depending on the operating system. I would like to mention them. The first parameter that we should take care of is ES table. It can be set to Unix STD or SHM-sex. This parameter defines which memory implementation will be used. If this parameter is wrongly set, system may not behave as expected. AAX platform works with segments, so only for this platform, parameter should be set to SHM-sex. The second relevant parameter that we need to check is ES implementation. It defines the implementation of the memory management on Unix-based operating systems. We can use values STD or MAP. Both are allowed. Normally on 64-bit Linux system, recommendation is STD. Value map works for Linux and Solaris, but not on HAPUX. On this table here, we can see which are the possible configurations and the mainly involved parameters. Let's start with AAX servers. As we have seen, parameter ES table should be set to SHM-sex, which switches to the alternative implementation of the extended memory. In this case, extended memory size is defined by this parameter EM total size MB. The amount of segments and each segment size can be set automatically using profile parameters mentioned on this note. This note also mentions that the areas for the ABAP table buffer and the ABAP share objects, which both are located on extended global memory, cannot be distributed over multiple segments. They must be formed from continuous memory, fitting in one single segment. As from the patch level specifies in this note, depending on your kernel release, there is a new version of SHM-sex implemented that removes the limit on segment size. To switch to this implementation, you need to set the profile parameter EA's SHM-sex version to 3. In the case of Windows platform, Note 88416 provides deeper explanation about the third administration memory management on Windows. Extended memory is dynamically self-extended up to the limit of the profile parameter EM max size MB, or until the address space in the Windows page file is used up. Parameter EM address space MB defines the total maximum size reserved for extended global memory and extended memory for a single user context. Its value is only relevant on operating systems that implement extended memory with map files, mapping extended memory in the address space of the process, like happens on Windows. This parameter can also act as an extended memory quota if it is set smaller than the ZTTE role extension. As we mentioned, it happens on AAX platform. Allocation sequence for dialog word processes and non-dialog word processes is the same on Windows, taking first extended memory and then taking heap memory. For Linux, 2 different memory management models are available, defined by parameter ES implementation. Recommendation is to set it to value std. Memory allocation sequence for the work processes and relevant memory parameters on each case are provided on these two nodes. With the map implementation, each active extended memory user context is mapped into a work process via an address window set by EM address space MB parameter. There are different monitoring tools that can be used to check the memory consumption on a running application server. We will see them also in the system. SAP pfpar command can be executed entering the path to the profile and then the check option. If we go to the system, we can see on transaction AL11, go to the folder Dear Profile. Then we can go to SE38 and execute command from operating system SAP pfpar check, then pf, and the path to the profile that we want to analyze. In this case, we have to take the location and the path to the profile. So if you run the command tool SAP pfpar using the instance profile and the check option, as we have just done, the output provides useful information. First, the total minimum requirement, shown here, is the memory which is allocated when starting the SAP system. Later, the total worst case requirement, shown here, is the maximum usage made of the various shared memory segments at the operating system level. This total worst case requirement value must fit into the available virtual memory. If more SAP instances are running on the same host, you need to summarize their worst case requirement. The tool SAP pfpar with the check option also verifies the parameter configuration and reports here if there are any errors that should be corrected. When there are memory dumps related to shortage on memory resources on transaction ST22, they normally contain more information about the reason of the dump, and they also show the amount of memory that was being consumed at the time of the dump. We will analyze each case on detail on the troubleshooting section. Then, with RS memory report executed from SAE38, you can check not only the allocation sequence on each application server that we have already seen, but also you can get an overview on the EG consumption and proc memory consumption. If we see this on the system, we execute from SE38 RS memory report. So here you can see an EG overview. If we go back, you can also display with EG consumer button the different consumers using EG memory. This EG consumer option is only available as from NetWeaver 7.4. For proc memory consumption, here, the button Work Processes show the current proc memory usage of all work processes and of the dispatcher of the local instance individually. Here, the button Server shows a summary of the proc memory usage. Next memory tool is transaction ST02, which provides a general overview of the memory that has been used. We go to ST02 on the system, and we can see the general overview of each area. Information is shown since the latest application server restart. We can see here on the top when was last restart. This transaction also provides an historic overview, clicking on this button, from previous days. Going through the path, detailed analysis menu, and then SAP memory, or by direct double click on transaction ST02, you can get more information here and here about the quotas that are defined on this server. Next one is transaction ST06. It offers an overview of the operating system resources. We can see it here in the system. Transaction ST06. It shows current values, previous 24 hours ones, and also history as well if you want to look back to previous days. On transaction SM04, you can get information about the memory that it's allocated for each user. Transaction SM04, the memory. By default, only here the extended memory is shown, but heap memory consumption can also be shown changing the layout. I will show you how. You have to click here in Change Layout, select the heap memory that you want to display and move to the left side, and then you will also get the display of the heap memory consumption. Note that SM04 gives you a snapshot of the memory which is being used in this moment, but it gives no information from past. In case a work process starts taking heap memory, either because the extended memory quota has been used up, either because the total extended memory has been exhausted, it will enter into brief mode. If this happens, this brief mode can be seen in transaction SM50 and SM66. Normally, if all work processes enter into brief mode at the same time, this means that the extended memory has been used up. Next one is SDF-MON. The main purpose of this report is to collect snapshots of monitoring detail and then store these details for later analysis. You can also go through transaction SDF-MON. It needs to be scheduled, and you can see here the information. Here. This tool helps to analyze the memory consumption in a line of time. This is scheduled in slots of 10 seconds. The last memory monitoring tool is transaction RSET20. It has monitoring 3 elements to generate alerts when some memory thresholds are reached. So let's check which are the most common dumps that we can get, and we will learn how to solve them in each case. First dump I would like to show you is memory no more paging. As we have seen, page area is first allocated in shared memory, and afterwards it is allocated on disk. The short dump memory no more paging means that the page file is set up too small. If we check this dump on transaction ST22, we can see that it says SAP paging overflow when storing data in the ABAP memory. In the dump, if we go down, we can identify which is the involved application server that is shown here, and which is the involved work process, which can be seen here. For these particular examples, data has been removed to keep information security. The error trace that we will find on the affected work process should be like this. We can see the timestamp matching the timestamp of the dump. Then we can check on STO2 transaction that max used value has reached in mem value plus the on-disk value. This memory no more paging dump can be solved by increasing the value of parameter rdisk.pg maxfs, as explained on this note. You should consider that the page buffer is normally found in data directory, and there should be enough free space in the disk where this directory is located. Those notes that are mentioned here collect information about this dump, and they also provide recommendations for the parameter value. Then we are going to analyze TSV to new page alloc fail dump. We have already seen which is the memory allocation sequence on each operating system. If the work process has taken its available extended memory quota and it has taken its available heap memory quota, this dump will be raised. Before the dump appears, you may find on the bottom of the page this memory low message. This is not an error. It means that after the program has finished, you should leave the transaction so that allocated memory will be released. Checking the information shown in the dump, we can see, for instance, which is the involved program, and we can also see the number of rows being allocated in that particular moment. The most important information that needs to be extracted on this TSV new page alloc fail dump can be shown here, is the amount of memory that was being used at the termination time. In this case, we can see that extended memory consumption matches with the defined extended memory quota, which is 4 gigabytes, and the heap memory consumption matches with the heap memory quota, which is 2 gigabytes. Depending on the work process type, the error that we will see in the corresponding work process trace will be this for dialog work processes or this for non-dialog work processes. This dump is deeply explained on this note 2180736. To solve it, general recommendation is to increase the corresponding heap memory quota and check if the dump still occurs. Apart from increasing memory resources, it is also recommended to check with the involved application area if selection criteria can be reduced. If we go once more to the dump, you can identify which is the involved transaction and the report in the dump itself. Go to User and Transaction section, and you can see transaction and program. And also you should check information on where terminated. Then involve the application specialist so they can verify why so much memory is being used. In the case of customized set programs, they have to be verified with the developers to fix the program. This dump can also appear with this name, TSV to new blocks no role memory. But you should check if memory consumption shown on the dump matches with the defined extended memory and heap memory quotas. Then the solution for the dump will be the same. If checking memory consumption shown on the dump, you may notice that the amount of memory being consumed do not match the quotas defined. In this case, the dump appeared not because the quotas were reached, but the dump appeared because the extended memory or the heap memory areas were exhausted. When the extended memory area is exhausted, this information can be seen in the dump itself. We can see this on the dump itself, that the extended memory has been exhausted. In those cases, errors shown on the trace file may change depending on the operating system. To solve this error, extended memory needs to be increased based on available resources on the application server. If the total size of the heap memory area has been exhausted, work process trace file will show this error. The trace also shows which work processes are taking the available heap memory. To solve this error, as mentioned on the trace itself, parameter ABAP heap area total should be increased. This parameter should always be at least bigger than the corresponding heap memory quotas. Both scenarios 1 and 2 are covered in this note already mentioned. Next dump is load no roll, which can be misleading because of the name. As we have already seen, the roll memory is no longer used, and all data is now stored in the extended memory. Therefore, load no roll dump is related to shortage on extended memory, as we can see on the dump itself. If we check on the load no roll dump, we can see that it says warning EM memory exhausted. We can confirm that the extended memory has been exhausted, checking extended memory consumption on transaction ST02 on the application server where the dump took place. There, we can see that the max use value has reached the in-mem value. Increasing extended memory size should solve this problem. This can be done either with EM initial size MB parameter or EM total size MB parameter, depending on the operating system. When changing extended memory parameter, remember that an instance restart is necessary to make this change effective in the system. There is no recommended value for the extended memory size, as it depends on many factors. If the database is installed on the same host, if there are other applications running there apart from SAP, etc. When extended memory is exhausted, work processes start allocating heap memory, and they enter into brief mode. If work processes are in the brief mode, they are only available to the user who was assigned last to this work process. This normally causes long waiting times for all other users because there are less dialog work processes. Also, on 7.4 release, we have seen that there is no role area, and the user context is stored on extended memory. If there is not enough space, the user context information cannot be stored. And problems with updates remaining in initial status in transaction SM13 may appear related to shortage on extended memory. So extended memory exhaustion should be avoided. Following dump that we will see is resize EM alloc error. It occurs with an error in the EG alloc call. This means that the program tries to allocate extended global memory and fails due to shortage on EG resources. You can see the error information on the work process trace file that is shown here on the slide. Error can also appear even if no dump is generated in transaction ST22. In order to avoid the dump, you should increase the parameter EM global area MB. This note 1514752 recommends to set this parameter to 5% or 10% of the total extended memory size. Remember that you can monitor the usage of this EG memory area with the ABAP report RS memory EG overview during runtime. System no-roll dump occurs when a program needs more memory, although not all the available memory is in use. Each transaction requires some memory space to process application data. If the operating system cannot provide any more space, this transaction is terminated. This system no-roll dump can be solved with the parameter setTT max mem request MB which limits the memory that can be allocated for a single memory request. The maximum value of the parameter is 2047 MB. If you are getting this dump, you should increase this parameter in case it has been modified to 2047. If parameter has already been increased, you should involve application area to execute the report with more restrictions, so it handles less data. The error that you will see in the work process trace file is this. You may also get same error under memalloc fail dump. You should always check the corresponding trace file from the involved work process to get more information on the reason of the error when you're analyzing any dump. And finally, what are the memory leaks? Memory leak means unexpected and significant uncontrolled increase in the memory consumption of an ABAP server. This kind of error is usually caused by a process consuming memory from the operating system and not releasing the memory when it is not needed anymore. You should first check if there's a known error causing this memory leak. So check involved regression node for your system patch level. Those nodes are always called known regressions in kernel 7 wherever and patch level whatever. And they contain errors that are known to the date that can potentially occur in this kernel patch level. More information can be found in this node 1802333. If no error is documented on the corresponding regression node, you should try to find out which process consumes most of the memory. This has to be compared with the amount of memory available to the operating system. In case this is a non-SAP process, for instance the database, the problem has to be covered from the owner of this process. In case this is an SAP process, this is normally a work process, but can be any other process from the application server. Once the process ID has been identified, you need to check the memory usage of this process. All the topics that we have covered along this webinar and many more can be found on the client-server technology wiki page. I would like to show you. This is the wiki page, the client-server technology wiki page. It contains information about all areas that are handled by the client-server technology area. The memory management section in particular describes the SAP memory management system, its basic functions, hardware and operating system requirements, and some of the most common issues. Also, most relevant notes here and frequently asked questions. You can always get more information with the online help documentation. So these are the most important points that you should remember. First, check which is the involved operating system, and if there is any special parameter or configuration that applies for that specific platform. RS memory and STO2 transaction provide a good help on memory management and good overview. No matter which dump we are analyzing,